The objective of this lesson is to understand what your student will be learning in 4th grade in relation to place value and fluency. In 3rd grade, students add, subtract, and round numbers within 1,000. Students in 4th grade extend their knowledge and are introduced to the thousands unit, which includes 1,000, 10,000, and 100,000. Students are limited to numbers less than or equal to 1 million. Students will use place value knowledge to correctly write numbers in different forms. Students will write numbers in base 10 numerals, which is also called standard form. Students will know where to place the comma. In this example, the comma was placed between the 4 and the 5 to separate the thousands from the units. Students will practice number names as well. Number names are also known as word form. Students would read the number aloud or in their head. Then the student could write the number out in words as if they were saying it. 4,578. This is especially difficult for students when there are numbers missing in the hundreds or tens place. For example, given the number 1,402, many students will write the 2 in the tens place because it is a number they hear next, so the number could be incorrectly represented as 1,420 or 142. With the continued focus on place value, students will compare numbers less than or equal to 1 million. Students also will be introduced to tenths and hundredths and how they represent part of a whole. They will develop an understanding in 4th grade of comparing numbers up to 1 million as well as numbers including tenths and hundredths. In 3rd grade, students were introduced to the concept of multiplying a 1-digit number by a multiple of 10. 3 times 10 equals 30. 3rd grade students could apply this concept to problems such as 5 times 30. The student would recognize 30 represents 3 tens. First, we would multiply 5 times 3 and then multiply that by 10. 5 times 3 is 15 and 15 times 10 is 150. So we can gather 5 times 30 equals 150. In 4th grade, students are able to build upon this background understanding. If I had a 4 in the ones column, the value of the 4 would represent 4. If I move the 4 to the left one place, the 4 now represents 4 tens. If I move it to the left again, it represents 4 hundreds. And if I move it to the left once more, it represents 4 thousands. Each time we move to the left, the value is 10 times larger than before. If I move the digit to the right, we would be decreasing my value 10 times rather than multiplying it. If I had a 4 in the thousands and I moved it to the hundreds, I have decreased my value 10 times. The power of the base 10 system is in the repeated bundling and unbundling of 10. When students have this base 10 understanding, the transition to decimals becomes smoother. If I took a unit cube and partitioned it into 10 equal pieces, I would have tenths. If I partitioned the tenths into 10 equal pieces, I would have hundredths. This means dividing one whole by 10 creates tenths, and dividing tenths by 10 creates hundredths. Having a strong place value foundation will ease the transition to other concepts taught not only in 4th grade, but through all grades. When I was a student in grade school, it was common to have assignments with many problems on a page. The more problems, the better, meaning fluency could have been interpreted as being fast to recall facts. Studies have shown that faster isn't smarter. Marilyn Burns said, "Speed with arithmetic skills has little, if anything, to do with mathematical power." The focus of mathematics now states that fluency means they are able to use strategies and methods that are efficient. Math time tests are not suggested for students. Imagine this scenario. A 4th grade student named Susie is sitting in class. Her teacher passes out a piece of paper full of math facts and starts the timer. Susie knows the class expectation is to complete the page with 100% accuracy before the timer stops. She starts answering the simple problems first and saves the more difficult problems for later. Susie frantically fills out what she can, knowing the clock is ticking. She realizes time is running out and struggles to recall a more difficult fact, feeling the pressure of speed. She feels that her mathematical intelligence is based off her time test score. Susie then internalizes the feeling that the test will determine if she is smart or if she isn't. I can relate to this scenario, and many others can as well. Many students become easily frustrated when solving math problems. Anxiety stemming from self-doubt about their abilities or fear of failure blocks their progress. Joe Boller, a mathematician who has studied the brain and how we learn math, states, "When people are stressed, pressure blocks the working memory in the brain, which is where fact recall is located. Time tests give students the message that math is about performance rather than learning. Students then may feel that memorizing facts is the most important thing in math and that being fast means you are good at math." Joe Boller also states that children who are fast remain fast, while children who are slower remain slow, and both will get slower as anxiety kicks in. In the book, Mathematical Mindsets, Boller states, "The powerful thinkers in today's world are not those who can calculate fast, as used to be true. Fast calculations are now fully automated, routine, and uninspiring. The powerful thinkers are those who make connections, think logically, and use space, data, and numbers creatively." There is a solution to help students with math facts that does not involve the pressure of a timing. In fact, learning math facts can be fun for students. Hands-on activities with manipulatives will give students a greater conceptual understanding of math facts. Students can see what is being taught while manipulating objects to see math happening. In an article titled Hands-on Help, Marilyn Burns states, "A picture may be worth 1,000 words, but while children learn to identify animals from picture books, they still probably don't have a sense about the animal's sizes, skin textures, or sounds. Even videos fall short. There is no substitute for first-hand experience." Along the same lines, manipulatives give students ways to construct physical models of abstract mathematical ideas. Using manipulatives may not be the way we learned as a child, but studies have shown manipulatives are great tools that add depth to students' understanding in mathematics. Students can explore strategies to support their understanding of mathematics. With the use of manipulatives, strategies, and regular exposure to math facts, students can develop automaticity. Students' understanding has depth rather than a memorized number without meaning. Fluency means flexibility, efficiency, and accuracy. Students who mentally use facts on a daily basis commit them to their memory faster. Kling and Bay Williams did a study using only textbook activities, weekly fact games, and task-based learning without any time testing or other rote math fact activities. By the end of the year, the students demonstrated automaticity, answering within 3 seconds 95% of the time. Our objective in this lesson was to understand what students will be learning in 4th grade in relation to place value and fluency. We met this objective by discussing how 4th grade students will add, subtract, and round numbers less than or equal to 1 million. We learned about different forms we can write numbers, such as base 10 numerals and number names. We talked about the base 10 system as repeated bundling and unbundling of tens. We also focused on the visual understanding of tenths and hundredths. Last of all, we discussed what fluency means and how to develop automaticity with math facts.